Hello, and welcome to the first in a series of screencasts on code katas. A kata, as the name implies from martial arts, is a session in which you practice some fundamental motions or fundamental concepts of your craft. In code katas, those fundamental concepts could be things like test-driven development, refactoring, even some fundamental uses of specific technologies. The idea behind this is that by repeatedly practicing these things, we move them into more of a muscle memory fashion. The idea, of course, with martial arts katas is that you practice your fundamental motions, allowing you to focus more on higher order concepts, and the same is true with writing code. The first one we're going to look at here is this bowling game kata. This is designed to practice the red-green refactor cycle of test-driven development. If you're not familiar with it, the idea behind this cycle of test-driven development, which is the cadence or pulse of the test-driven process, is that whenever you need to implement something in your code, whether it's a bug fix, a simple logical change, or even an entire new feature, the first thing you should do is write a test to validate that feature or that new code. Now, since that code hasn't been written yet, that test will of course fail. This is the red part of the cycle. Having done that, the next thing you do is write the simplest thing possible, whether it's minimal code or at least minimal complexity, in order to get that test to pass, in order to validate the functionality that's being tested. This is the green part of the cycle. Having completed that, you now have a series of tests that you can rely on to validate your functionality, and you enter the refactor part of the cycle where, relying on those tests, you can change the code, clean it up, essentially refactor it to something more maintainable. And as long as those tests still pass, you still know that the code works. And you could repeat this cycle over and over again many times. You could go through this cycle entirely in the span of 1 or 2 minutes. As long as you're writing tests to validate the functionality, then you always know that that functionality you've written is valid at least for the tests that you've designed. So let's start with this bowling game kata. The purpose here is to design a simple engine for calculating the score in a game of bowling. So we might think that if we were going to design something like this, we'd probably start writing some objects. We'd write a game object, we might write a frame object, because each game is going to have 10 frames. We might have some sort of role functionality, maybe some object in and of itself, or functions on those objects. But we don't want to really get into that at this time. We don't want to start writing these objects because that's code, and it's code for which we don't have tests. So we're going to start by writing a test. Let's just call this class game tests. And our first test is a very simple one. Can create game. Now this test, of course, fails because there's no such thing as a bowling game. So now that's the red part of this cycle. Remember that failing to compile is still a fail. So let's go ahead and create the class. We'll do the simplest thing possible in order to get this test to pass. In fact, I'll pin this window since we'll use this a lot. And so now that's green, so we can refactor. And there's really nothing to refactor, nothing to be cleaned up. So we're fine there. So that seems a little superfluous, and in fact, you might, as you speed up, skip the simple tests. You'll find that in Kent Beck's test-driven development book, he encourages that when you're in a really good cycle, you could start taking larger and larger steps. skipping some of the simple things. But if at any point during that cycle you start to fail, then you scale that back and go back to the simple things. So let's go to our next test. Let's see, I think can roll gutter game would be a good test. And we need to roll the pins, I suppose. Let's see, how many rolls would there be in a gutter game? If there are 10 frames and each frame has 2 rolls, that's of course 20 rolls. So, of course I'm calling a function that doesn't exist, so that's going to fail. We expect a score of 0. And of course, that's a property that doesn't exist. So now that test fails. So let's go ahead and implement that. In fact, we can demonstrate the failure right there just by not compiling. So that brings us back to the red part of the cycle. So let's implement this so that we can be green again. Let's see, we need to have a roll function which accepts an integer, and we need a score which returns an integer. Now we're not actually doing anything in any of this code, but the default value for an integer is 0, and so we find that the test passes. So we're good. We don't have to implement this. We might be tempted to start keeping track of the score, start putting some functionality in here, but we don't have a test for that functionality yet. So let's see, now that we're in the green stage, let's move on to refactor. Is there anything we can refactor here? Certainly is. We have this repeated code, and so if this test were to fail, this test would fail for the exact same reason. So this entire first test is superfluous. Run our tests again. We're still good. Let's move on to the next test. Can roll all ones. Now we already see some repeated code here that we can refactor, but we're not at that stage yet. This is the red part of the cycle. And if I rolled a 1 20 times, then I can expect my score to be 20. Run our tests. Find that a test fails. Failed as expected. We expected a 20, we got 0 because we haven't implemented that functionality. So let's implement that. We'll make that private in a minute. I'm really tempted to make that private right now, but we'll put that in the refactoring step. So let's say score plus equals pins. And now run our tests. The tests pass. So let's do our refactoring. Before we get to those, let's just refactor this a little bit. So I want that setter to be private. That's successful refactoring. Let's go back to the tests. Well, we have this bowling game object that gets initialized each time. We can refactor that. See how the tests are going. Still pass. And we can refactor this loop as well. Let's pull that out into a helper method. Let's call it roll many, and we're going to put a couple of parameters on this method. Let's see. We want the number of pins and the number of rolls. Oh, I completely messed up. I thought that was coming out at the bottom. We want it here. So that's pins. No, sorry. That's rolls. That's pins. And here we rolled 0 20 times. Let's move this helper method to the bottom where I thought it was, where it belongs. I don't really need that anymore. And then here we roll 1 20 times. Let's run our tests again. We still pass. I think that's good for the refactoring. Let's move on to the next test. Can roll spare. Now in this case, we want to roll a couple of specific things before we roll many. And those specific things will be, let's see, they have to add up to 10, so let's say game.roll 5 and roll 5 again. And then to test the scoring, I'm going to roll 3. And now we need to roll, let's say, a 0 17 times. And so the score for this, for scoring a spare, would be the total value of that frame, which is 10, plus the next pin, plus the next roll. So we're up to 13 for the spare frame, and then the additional 3 for that next frame. So our score should be 16. Now this test will of course fail. So let's go back to see how we would implement that. So how are we going to maintain that score? Well, we could have some logic here in the getter. In fact, we probably want to do that, don't we? We probably want to put some logic in this getter. But then how are we going to implement that logic? Let's say when we're testing this, we need to have some kind of flag to track whether or not the last time we rolled was a spare. We'd have to use that for a strike later on too. What this is implying to me is that right now our design is wrong. In fact, if we look at this, what is roll doing? Roll is calculating a score, but its name implies that it's just recording a roll. And score isn't calculating anything, but its name implies that it calculates a score. So we want to change this design a little bit. Now, since that's going to be refactoring of existing functionality, we need to get back to a point where all our tests pass. So let's get rid of that test for a moment. All our tests still pass. So now we can continue this refactoring and change the design a little bit. So since score has a private setter, we're probably going to want to be able to take that setter out entirely and have score just calculate something. So first, let's have a backing field. Roll is just going to want to record the rolls. So let's have a list of integers. Alright, so we can do that, and then here we want to have a getter. no setter. So that's going to fail down there, but you don't need to worry about that. The getter is just going to return the sum of the rolls. See, does this work? Yep, that was a successful refactoring. So now we're storing these. So let's go back to this test. Run all of our tests again, get us back to that red stage. And so now we need to implement that. So let's see, if we're summing them here, well, we still need to find a way to know whether it's a spare or not. So let's see how we would do that. Instead of summing these, well, no, you know what? If we're going to make a change, I was going to say instead of doing a sum, we have to go through a loop. But that's a change. So let's back out this test. Let's make that change. Alright, things are going well here, so I'm going to speed up a little bit in the sense that I know this isn't going to work for the spare, because if we calculate that these two 5s add up to 10, let's say rolls I and rolls I plus 1 or I minus 1 add up to 10, then we call that a spare. But what if I rolled a 3 and then two 5s? Those 5s cross a frame, and so that wouldn't work either. And so while we're here, we're going to continue to refactor, and we're going to loop through some frames instead of the rolls. And in order to do that, we probably want a list of a static size. So, you know what? Instead of a list, I'm just going to make this an array. It's going to be an array of 20 rolls. So, you know, I actually forgot the how to initialize an array. Is it like that? That seems to work. So rarely use arrays these days. And then we need to know what is the current roll. So rolls current roll, which we would also increment, equals pins. Array has a length. Let's see how we're doing there. Test still passed, so we're still good. And now we need to loop through some frames here instead of through the rolls themselves. So let's say for frame equals 0, frame is less than 10, now what are we going to do here as we're going through these frames? Well, we want to grab that score, so score is going to equal rolls of rolls of frame. Well, that's not right. So frame plus plus, we're not counting frame, we need a separate counter. Rolls of I plus rolls of I plus 1. Let's return score there. Now we still need to increment I, so let's close this loop. And I gets incremented by 2. And so this should work because even if we roll strikes, which we haven't gotten to yet, we're still going to have this already initialized array. In fact, you know what? We're going to initialize this to 21 because you could roll 21 in a game if all of them were strikes. Let's see what our tests say. We're still passing. And so now we can actually refactor this a little bit. I don't like I as a name, so what would we want to rename that? How about roll index? I think frame is still fine for a name. Test still passed, so I think we're good. So let's go back to this. It took a long time to get us here to address this test again. So now we're back in the red part of the cycle. Let's see if we can do something here. So how are we going to implement this? We want to know if something is a spare. So as we go through the frames, if rolls roll index. Maybe that name wasn't as good as I hoped it would be. Plus rolls of roll index plus 1 equals 10, and that's a spare. So score would equal rolls of roll index plus rolls of roll index plus 1 plus rolls of roll index plus 2, because we get the first one from the next frame. Else this how does that work for our tests? That passes. So we can refactor this now. Let's go back to these. Do we need to refactor this at all? No, I think these are pretty clean. Let's clean this up a little bit. And we're starting to get a lot of little operators here. We're starting to get a couple of levels of abstraction that we probably want to strongly name. So let's pull out some methods here. I'm going to call this one is spare. And let's see, these other ones we probably want to change these as well. Get spare score. In fact, these helpers can move down lower, but we'll change that later. Let's call this get standard score. So that reads a little more cleanly now. If any given frame is a spare, get that score. Otherwise, get the standard score. Let's test this. We're still good. So let's go back and go to our next test. Now we want to test a strike. Now let's see, how would we score a strike? Well, the first one, of course, is going to be 10. That's a strike. And then the rules would be that that frame includes the next 2 rolls. So let's roll something like a 3 and a 4 for that next frame, so that frame is a pretty standard frame. And then we can roll, let's see, is it 16 more? Yeah, because the first frame only had one roll instead of two. So let's roll many. I want to say 0 16 times. And our score should be, let's see, 10 plus 7 for the first frame is 17, and then another 7 for the next frame, so the score should be 24. And we know this will fail. So let's go ahead and implement that. So we already have a pretty good structure here. Let's just continue with this structure. If roll index equals 10, move this to an else if, then score plus equals rolls of roll index plus the next two rolls. This looks very similar to the calculation of a spare, sort of coincidentally. We might address that in the refactoring. And now, well, we don't need these. Let's see if that works before we go any further. It does not. Why does that fail? Expected 24, actual 21. Let's see. It's off by 3. It means it skipped one of these. I think the reason it did that is because we incremented by 2, even though that first frame only has 1. So let's move that incrementer into our loops, into our conditions. That passes the test. So let's do some refactoring. Is there any refactoring to do on the tests? I don't think so. We could pull this out into a roll spare method and this into a roll strike method. I don't think that really buys us anything for simplicity. But this, we want to continue our pattern here. Call this isStrike. And we'll call this getStrikeScore. We don't really need to see those anymore. Just as a sanity check, make sure we're still green, and we are. And let's see, is there any further refactoring? You know, we could try to pull this out into something, but I don't think this duplication is really killing us because this is a pretty easy to follow pattern. If it's a strike, do that. If it's a spare, do that, and so on. I do want to reorder these because they're getting a little unsightly. First, let's move the public to the top because these helper methods aren't really necessary. And let's put them in a sensible order. That's a little cleaner now. And even though we didn't change anything, it's always good after you make any sort of code modification to just run those tests again. But let's go on to our next test. This is probably going to be our last test. It's can roll perfect game. Now let's see, how many rolls would be in a perfect game? Well, we'd probably, we know the score is going to be 300. That would be 1 strike for each frame, so that's 10 strikes, but then the last frame you would continue with 2 more as long as the second one, as long as that next one, the first of those 2, was also a strike. So, let's roll many. We roll 10 pins, 12 times in all. The score should be 300. Let's see where we are in that cycle. And in fact, we didn't even need the red-green refactor cycle this time because we were immediately at green. And I don't see any more refactoring we can do. We didn't change anything in this implementation. And that's pretty much it. And so what we found here, through the red-green refactor cycle of test-driven development, is that as each test was driving our implementation further along, we were able to get rid of earlier tests that we didn't need, for example, the one that just tested whether or not we could initialize the class. And we kept the implementation as simple as possible. We don't have an object-oriented design here because we don't really need one in this case. We have an engine that accepts roles and calculates a score. And that was the original requirement. So that's it for our bowling game kata. I encourage you to practice this kata and any other ones you find as often as possible. I was a little slow on this one because, admittedly, I'm a little out of practice on it. And so I'll be running through this again over and over. And thank you for watching.